Hello guys, welcome to my channel. In this video we are going to be drawing an hypocycloid. An hypocycloid is a curve traced by points on the circumference of a circle which rolls without slipping on the inside of another circle. The construction of an hypocycloid is the same as an epicycloid. The only difference is just that in an epicycloid the rolling circle is outside of your directing circle. That is, an epicycloid is given like this. So for an epicycloid, this is our rolling circle here. So this is our directing circle here. That is for an epicycloid. This is our rolling circle and this is our directing. This is epicycloid. Why an hypocycloid? The rolling circle is inside of the directing circle like this. This is an hypocycloid here. That's just the only difference between an epicycloid and an hypocycloid. So we have been given a question on the screen which says a circle of 50 mm diameter rolls on the inner side of the circumference of another circle of 160 mm diameter. Trace the locus of the point on the circumference of the rolling circle for one complete revolution. We are also asked to draw the normal and the tangent at 0.45 mm from the center of the directing circle. So first of all, we are going to draw a straight line like this. This is the first step. So from that straight line, I'm going to draw from 60 degrees from this point like this. You can actually use any angle, but for the purpose of this video I'm going to be using angle 60 degrees. So I'll label here as point O. And as we can see, they said the diameter of the directing circle is 160 millimeters. So definitely the radius is going to be 80 millimeters. So we are going to pick our point 80 millimeter to this point. I'll label this point as point P. Now we are also given the rolling circle to be 50 millimeter diameter. If you check what I said in the beginning, is always inside. For an hypocycloid it is inside. So I'm going to pick my radius of 25 millimeter, which is going to be in this place. So this is going to be C. I'm going to pick this place as point C. So I'll pick my compass now from point C to point P. I'm going to draw my circle. So this is my rolling circle here. This is our rolling circle. So now what we are going to be doing next, we are going to be dividing this particular circle into 12 equal parts. So I'll pick my 360 degrees set square like this. So we are going to be dividing this circle into 12 equal parts like this. If you still find issue in dividing a circle into 12 equal parts, you can probably check my previous videos. I did the two different methods at which you can divide a circle into 12 equal parts using the compass method and the set square method. So like this. So now I've divided my circle into 12 equal parts. We are going to be labeling this parts of this circle because it is very important for us to label it. So I'll label this point as point 12. I'll label this point as point 12/0. Then give this place as point 1, 2, 3, 10, and 11. Your labeling is very compulsory because it will help when you are drawing the remaining parts of your curve. So now from point O to point 12, I'll pick my compass. From point O to point 12, this P point here, I'll draw a very perfect curve. So from this point to this point, I'll draw my perfect curve. So I'll be labeling this point as my point E. Let me label this point as point E. So now from point 1 and 12, this point 1 and 12, you can actually use point 1, 12 and 11, any point, but just make sure you are picking this particular point, that is this one of the lengths of the line we have divided into 12 equal parts. So now you mark your first point. Then from here we are going to be dividing this into 12 equal parts. So now this is 1, 2, 3, 4, 11, and this is 12. We are going to be drawing a straight line from this point 0 passing through those points we have marked above. So it's going to be like this. This is the first point I marked, this is the second one, and this is the 12th point, that is, this is the last point we are going to be drawing. Now we are done with drawing our straight line, so we are going to pick our compass now, place it at this point 0. From point 0 to point 1, that is this point 1, passing through point 11, 1 and 11, we draw our curve like this. Then to point 2 also, point 2 is going to pass through point 2 and point 10, so we draw our curve like this. Then through point 3 and point 9, we adjust our compass like this. Then point C, we place it at this middle point, which is point C, adjust our compass like this. Then place it at point 4 and 8 like this. Then we place it at point 5 also, and point 6 here. So this is going to be it like this. So we are going to be picking this center, that is this center here, as C1. We are going to be labeling as C1. This is our C2. Please, if you are finding value in this video, please kindly hit the subscribe button. If you are yet to subscribe, like this video, comment your idea about this video in the comment section. So this is C12. So now we have labeled this our points as C1 to C12. So in order to pick our points for the hypocycloid, we are going to pick the radius of this rolling circle, which is 25 millimeter diameter. We are going to pick the radius, then place our compass at C1. Placing it at C1, we are going to mark this point 1, which is going like this. We'll mark point 1, that is our first point. We'll place it at C2 also. Point 2, we mark point 2. Place it at C3, point 3, this curve that is going on 3, we mark. Then place it at C4, point 4, we mark this point. Place it at C5, this is the line of C5, we mark here. Place it at C6, so we mark this curve of C6. C7, 5 and 7 are on the same line, so this is where we are going to be marking. C8, this is 8 and 4, so it's going to be like this. C9, this is the line for 9 here, so we mark it like this. C10 is going to be here, this is 10. Then C11 is going to be here, and then C12 like this in this place. So this is our points here. From here, points here, we are going to draw our hypocycloid. So now, using my French curve, I'll pick these points like this from here. You can actually also use broom, anyone you are comfortable with, but for the purpose of this video, I'm going to be using a French curve. So this is going to be like this. So I'm thickening the curve out. I'm thickening it out. So this is our hypocycloid. We are also given a question, never to forget, to draw the normal and the tangent to the curve at point 45 millimeter from the center of the directing circle. In order to draw that, we are going to, this is the center of our directing circle, we are going to pick 45 millimeter on our compass. We will place our compass at the center O, then mark this point on the curve of our hypocycloid which we have drawn. I'll label this point as my point J. So this is 45mm. I've actually marked there. From this point J, I'm going to be measuring 25mm, which is the radius of the circle. I'll pick from this point, then to this center circle, to this center here, I'll place my compass there, and I'll be labeling here as point K. So I'll draw a straight line from here to here, like this. From point O to passing through point K, I'll draw my straight line like this. This is my straight line. So now from this particular point here, I'll label here as my point L. From this particular point here to point J, I'll draw a straight line also. So this particular straight line I've drawn is going to be my normal. This particular straight line I've drawn is going to be my normal. The normal is always perpendicular, that is at angle 90 degrees to the tangent. I'm going to pick 90 degrees on this normal here. So this is 90 degrees here. So I'll draw like this. Like this. So this is my tangent. This is my tangent to the hypocycloid. Meanwhile, this is our hypocycloid itself. This is the hypocycloid itself, and this is our rolling circle. This is our directing circle. So if you find value in this video, kindly hit the subscribe button, share with your friends, and if you find anywhere that is not actually explanatory enough, you can comment in the comment section. I'll find something to do about it. Thanks for watching. Peace.